I'd like to take a look at a graphical example for us to really engage with the idea of definite integrals being areas, and in particular net areas if we have positive and negative regions. So here's a picture of a function that we can take a look at. So we're going to take a look at the integral from -3 to 2 of f of x dx. Now remember, when we see this, we're thinking the net area underneath this function between the function and the x-axis. So for -3 to 2, that's going to be from -3 to 2, our function is positive the whole way. We would like to calculate the area of this region. Now, because this is a geometric shape, we can use areas that we're familiar with, right? The shape here is a triangle. So this integral is simply the area of this triangle from -3 to 2. So the area we know is going to be 1/2. The base in this case is 5. And then the height we see is 4. So this is equal to 10. So the integral from -3 to 2 of f of x dx is 10 because that is the area, and we're just a positive area because we're above the x-axis. Now if we take a look at -5 to 3 of f of x dx, now if we're looking at this interval from -5 to -3, now we're below the x-axis, so we're really looking at this region. Again, we're using the area formulas of shapes that we know. This is a triangle, so again, this is going to be 1/2. Our base in this case is 2. Our height, if you can continue looking at this line, this has a slope of 1. This is also going to be 2. But because we're below the x-axis, this is a negative area. So we have a negative area, so this ends up being -2. So that's that region. This region over here was 10. So now if we look at the integral from -5 to 2, so now if I go from -5 all the way to 2, remember we're doing net areas, so I have my positive area, I have my negative area. And so we just calculated both of these. And so using the properties that we know, this is the integral from -5 to -3 of f of x dx plus the integral from -3 to 2 of f of x dx. And this integral, first one we said was -2, the next one we said was 10, and so the net area is 8. Net area is 8. And the last one now, if we look at the region from 2 to 5, so if I go from 2 over here to 5, I have to figure out the area of this region. Now, if you know the equation of a trapezoid, great, go ahead and use that. If you don't, just subdivide this into things that you do know. So you know that this is the area of a triangle here. So find the area of this triangle. That's going to be 1/2. My base I see is 1. My height I see I go all the way down here to a -4. So I'm down over to 4. But remember, I'm below the x-axis, so this is negative. And then I have this other region. This is just a rectangle. It has a width of 2, a height of 4, and this is again negative. So I have 2 times 4. So this becomes a -2 minus 8. This is -10. So this becomes, this total area over here is 10, but again, it's a -10 because we are below the x-axis. So as a note here, you could use this for any types of shapes. If you get something that's circular, use the equation for the area of a circle. If I instead asked you something, say between 1 to 3, again, you would find the area of each of these smaller regions. So just subdivide and use that as your go-to technique if you're just given a graph.